When you think of the universe, what is the first thing that comes to your mind? Stars, galaxies, or black holes? Yes, although all of these structures are incredibly interesting and fascinating, one of the most intriguing and mysterious structures in the universe is actually planets. This statement might surprise you at first because, after all, planets are quite common objects in the universe, and you might think that the formation processes, conditions, and behaviors of most of them are similar to one another. However, that is not exactly the case. In fact, certain exotic types of planets that have no direct counterpart in our solar system but have been discovered in other star systems are far more mysterious and fascinating than black holes and many other structures. Perhaps the most prominent and attention-grabbing among these exotic planetary types are the super-Saturns. Today, together with you, we are taking a detailed look at super-Saturns. But before we move on to our video, don't forget to support me by liking the video, subscribing to my channel, and leaving a comment to share your thoughts. Now, if you're ready, let's embark on an intriguing journey towards super-Saturns. The concept of a super-Saturn might sound quite simple when you first hear it. It might be understood as just a larger version of Saturn, but the reality and the phenomena of super-Saturns are much different. This is because super-Saturns are not just larger planets, they are celestial bodies that challenge planetary formation theories and behave unusually in terms of density, structure, and ring systems. Before moving on to super-Saturns, I need to briefly mention Saturn itself. Despite its massive size, Saturn is the planet with the lowest density in our solar system. In fact, its density is so low that theoretically, if it were placed on a giant ocean, it would float on the water. The biggest reason for this is that Saturn is largely composed of hydrogen and helium. It has no solid surface and consists mostly of gas and liquid layers. However, what makes it special is certainly not just that. Saturn possesses a tremendous ring system, and this ring system makes it unique, both in terms of appearance and the strange objects within it. This is precisely where super-Saturns come into play. In astronomical literature, the term super-Saturn is generally used for planets that, similar to Saturn, have low densities and fall into the gas giant class, but surpass Saturn either in terms of mass or in particular their ring systems. Yet there is a very fascinating point here. Even though some super-Saturns are as massive as Jupiter, they can have much larger diameters. This indicates that they possess incredibly low densities, and some might even have lower densities than our own Saturn. So, how do these super-Saturns form? As I briefly mention in almost every video, planetary formation is actually a natural byproduct of star formation. When a star is born, a spinning disk of gas and dust forms around it, and the particles within this disk collide and grow, eventually forming planets. Gas giants, on the other hand, usually form through a two-stage process. First, a core composed of rock and ice emerges, and then this core grows by rapidly pulling the surrounding gas toward itself. The critical difference in the formation of super-Saturns occurs during this gas attraction process. Some of these planets gather gas very quickly, but during this process, the dynamics in the system, such as the star's radiation, disk density, or the presence of other planets, prevent them from growing even further. Consequently, gas giants emerge that have a huge volume but a relatively low mass. In other words, gas giants that are inflated just like a balloon come into existence. This puffy structure is even more pronounced, with a glaring difference, especially in hot Saturns, meaning super-Saturns that orbit very close to their host stars. These planets are so close to their stars that their surface temperatures can reach thousands of degrees. This causes their atmospheres to expand and makes the planets appear much larger than they actually are. So, some super-Saturns are not actually massive in a true sense. They are simply overheated and expanded planets. However, what truly makes super-Saturns special is almost always the ring systems they possess. One of the most remarkable examples discovered so far is the planet known as J1407b. This planet is located in a young star system about 430 light-years away from Earth, but what makes it special is neither its star nor its star system. What makes it special compared to other planets is the ring system around it. This ring system is mind-bogglingly massive, and it is so wide that its diameter reaches approximately 120 million kilometers. This means it has a ring system hundreds of times larger than Saturn's rings. To make a comparison, while Saturn's rings span an area of a few 100,000 kilometers, the rings of this planet are large enough to encompass a major part of a star system. These rings are, of course, not just an ordinary cloud of dust. Inside them are gaps, density differences, and most likely the tracks of exomoons in the process of forming. This ring system looks just like a protoplanetary disk around a young star. In a sense, we can even think of this planet's ring system as a moon nursery disk. This shows us something extraordinary. We are actually able to observe this planet not just with a ring system, but directly alongside a maternity ward for moons. From this point onward, we need to take a closer look at ring physics, because the key to understanding supermassive Saturns lies in understanding how these rings behave. First of all, there are specific conditions for a ring to form around a planet, and the most important of these is the Roche limit. The Roche limit is a highly crucial and critical boundary for planets that determines how close a moon can get to a planet. If a moon crosses inside this limit, the planet's tidal forces overcome the moon's own gravity and tear it apart. The material resulting from this disintegration forms a ring around the planet. However, in super-Saturns like J1407b, this process may have occurred on a much grander scale, because this cannot be explained simply by the tearing apart of a small moon. For a ring system of this size to form, objects the size of Mars likely had to be shattered. What's even more fascinating is that these rings are not static systems. In other words, they constantly evolve and undergo change. The ring systems we observe right now might look vastly different if we were to look thousands or hundreds of thousands of years from now, because the particles within the rings collide, merge, or can even be ejected from the system. Over time, new moons can form from within these rings. If we have grasped the concept of ring systems, we can now move on to cotton candy planets. Although it sounds strange and funny as a name, the term cotton candy is actually very fitting for these planets because, as I mentioned at the very beginning, they have extremely low densities, just like cotton candy. Earlier I mentioned that their densities are quite low due to the gases super-Saturns contain and the fact that they can be inflated planets. Another major factor that determines the density of these planets is their internal structure. If a planet's core made of heavy elements is small, meaning it doesn't have a large rock and ice core, the gas layers can spread over a much wider area. This causes the planet to have a puffy appearance. However, unfortunately, this situation does not last forever because these types of planets are generally in an unstable state. Over time, their atmospheres escape into space, especially super-Saturns that are very close to their stars lose a large portion of their atmospheres due to stellar winds. In a way, stellar winds literally peel the planets like a piece of fruit. When this process takes millions of years, the planet loses a significant portion of its mass. In fact, some scientists believe that these types of planets can transform into smaller but denser planets over time. This means a super-Saturn might actually be a temporary phase in a planet's life cycle. This very situation has caused certain groups to clash with one another, because one side argues that if super-Saturns are just a phase as mentioned, they shouldn't be treated as a distinct planet type. The other side defends the idea that this phase lasts for millions of years, and therefore super-Saturns can be considered a type of planet. At this point, I am actually curious about your opinions. What do you think? Since this is a phase, do you think it can be a planet type? My opinion is that it definitely can be. To give an example from our own star, our Sun is currently going through the phases that a normal star goes through, and as it transitions into different phases in the coming years, its classification changes. Although our Sun is currently a yellow dwarf, meaning a G-type main sequence star, it will transition into the red giant phase in the future and will then be a red giant star. In that case, classifications in stars would have to disappear and only phases would be mentioned. Therefore, even though super-Saturns are a life phase of a planet, I think they can also be named as a distinct planet type, just like our star, or rather, just like stars in general. In short, dear friends, super-Saturns are not just what we call planets that are larger than Saturn. Each one has distinct characteristics and conditions. Today, I wanted to explain this to you and clear up the confusion in people's minds. I hope you enjoyed my video. At this point, I actually have a special request for you. Could you please write in the comments which topics you want me to cover in future videos? This way, I can prepare videos that appeal directly to you and save myself from constantly wondering which topic to tackle next. Anyway, if you liked my video, don't forget to hit the like button, subscribe to my channel to support me, and turn on notifications to be informed about upcoming videos. See you in our next video. Take very good care of yourselves. Goodbye.